Question 5. So sorry about that. That's absolute nonsense there. I don't know how that crept in there. It doesn't affect your answers at all or your marks in any way. I thought it did at first, and that's why you'll see that I gave you 6 extra marks, but terribly sorry I took it away again, because it actually didn't affect your marks. Determine the value of p such that f is continuous at x equals minus 1. So there's f of x. We've got to consider continuity. Let's remind me, a function f of x is continuous at x equals a if the limit of f of x as x tends to a equals f of a. Now that's got a few things hidden in there. F of a must be defined, or we wouldn't be able to write that. The limit of f of x as x tends to a must exist, or we wouldn't be able to write that. And then, of course, f of a equals that limit. Now, even this goes one step further. A limit only exists if it has a left and a right limit. They must be equal to one another, or that left limit and right limit don't exist. And that's actually what we're going to use here. The right limit of f of x. So this is at x equals minus 1. So on the right of x equals minus 1, we've got x minus 2. Therefore, minus 1 minus 2. I'm substituting minus 1 into this. On the left of x minus 1, we have the left of minus 1, we have px, which means I have to substitute minus 1 into px. All right, so for the limit to exist, the left limit must equal the right limit. I found the right limit. The right side of minus 1 is here. So therefore we substitute minus 1 in there. The left side of minus 1 is here. So therefore we substitute minus 1 in there. We get minus p. And for the limit to exist, which we need to occur for continuity, these two limits, left limit, right limit, must be equal. And that gives us p equal to 3. Now determine whether f is continuous at x equals 3. So we have to find, first of all, we have to see if the limit as x tends to 3 of f of x is equal to the limit as x tends to 3 of f of x. And of course, we have to see if the left limit equals the right limit. So f of 3 equals 1. And how do we know that? Well, because that's the function that determines what x will be at 3, not this one, because this is greater than 3. So therefore, we substituted 3 in for x there. The limit, the left limit of f of x as x tends to 3, well, the left limit acts on this. Therefore, it's going to be 3 minus 2, which is 1. The right limit, we're going to have to substitute into here. To get the right limit, we're going to substitute 3 into there, and we get 1. So the left limit equals the right limit, therefore the limit exists. And the limit is 1, and it's equal to f of 3. And therefore, f is continuous at x equals 3. Determine the limit of f prime of x as x tends to tends to 3, the left limit, and the right limit tending to 3 for f prime of x. Well, the derivative of x minus 2 is 1. The derivative of minus 2 into x minus 3 all squared plus 1 is going to be the 2 multiplies down, giving us minus 4 times x minus 3 times 1 for the inside derivative, and the 1 drops away. So there's the derivative on the left, and there's the derivative on the right. Now we asked if f is differentiable at 3. Well, oh, we haven't finished there. Sorry, yes. We had to find the limit as f of x tends to 3 from the left. So therefore, I'm going to not even worry to substitute anything because this is a constant. It's the limit of 1 as x tends to 3, left limit, which equals 1. And on this one, as 3 plus, we're going to substitute 3 into this one for the right limit. So we'll substitute 3 into there, and we get 0. So we have 1 for the limit of f of x as x tends to 3, the left limit, and we have 0 for the right limit. The left limit comes from substituting into the whatever it is on the left of 3, and the right limit comes from substituting whatever it is on the right of 3. But remember, it's derivatives we're now doing. The limit of its derivative, limit of that one's derivative. Is f differentiable at x equals 3? Well, let's have a look at differentiability. F of x is differentiable at x equals a if f of x is continuous at x equals a. So those continuity rules must apply. We've already proven it is the case at x equals 3. So that's fine. F of a exists. F prime of a exists. Now for f prime of a to exist, the left limit must equal the right limit. And that is the case. Not differentiable because the limit doesn't exist. The limit doesn't exist, and the reason being the left limit is not equal to the right limit.